that is EFA. This is our outline. There are 4 agenda points you can see here. What is exploratory factor analysis? What are the assumptions of exploratory factor analysis? Third, what are the terminologies we use in exploratory factor analysis? And we'll consider a case study related to exploratory factor analysis. Now, what is factor analysis? So, factor analysis is a technique that is used to reduce a large number of variables into a fewer number of factors. So, in factor analysis, what we do? We reduce the large number of variables into less number of factors. So, it is often used to identify a small number of factors that explain most of the variance embedded in a large number of variables. So, as we have discussed in first point, we reduce the large number of variables into less number of factors, and then these factor must explain most of the variables. So, what exactly we are doing? We are reducing the data. So, that's why thus the factor analysis is about data reduction. So, it is known as data reduction technique, or it is also known as dimension reduction. Now, also factor analysis is a interdependence technique. So there are two types of techniques. One is dependence technique and another is the interdependence technique. So in interdependence technique, there are no independent variables and no dependent variables. Here the variables are interrelated to each other. So that's why it is known as interdependence technique. So factor analysis is an interdependence technique. Now what are the objectives of factor analysis? So first one, as we have discussed in the definition itself, it is for the data reduction. So we are reducing the large number of variables into less number of factors. Second is the identification of factors. So once we have reduced the variables into less number of factors, then we identify the factors and we give name to those factors. Now the question is, why to convert the large number of variables into fewer number of factors? Why to convert the large number of variables into less number of factors? The question is, when any organization or any company, they want to do something like that, they want to provide the service, they want to provide, or they want to produce a particular product, and they want to give that particular product to the customers. But when they produce such type of product, and before that, when they take the responses from the respondents, there are n number of variables the customers require. So it is difficult to find out, it is difficult to study the large number of variables. Suppose we have to study the 50 variables, 100 variables. So it is difficult to concentrate on each and every variable. So what we do, we combined the similar type of variables into one factors, so that it is easier for the organization to concentrate on the factors rather than the large number of variables. So that is the main reason we reduce the large number of variables into less number of factors. Now there are types of factor analysis. So factor analysis are of two types. First, we are talking about the exploratory factor analysis. In short, we call it EFA. And second is the confirmatory factor analysis. We call it CFA. So what is exploratory factor analysis? From the name itself, you can see here exploratory. So the researcher want to explore. It means that the research in which we do not have the proper factors are available, parameters are not available, models are not there. So earlier research, we do not have the proper parameters or the factors are not there. So that's why in such cases we try to find out the factors. So it is known as the exploratory factor analysis. So in short, we call it we do not have the proper factors or the component or the parameters are not available or any model is not there. So in that particular case, we do exploratory factor analysis. Whereas in case of, from the name itself, you can see here confirmatory factor analysis. So something which is already available. So factors are there, model is there. So we just want to confirm whatever the factors we have taken is correct or not. So here the model or the component or the factors are available. So in that we want to just confirm. So here it is confirmatory factor analysis. Today we will discuss about exploratory factor analysis. Now, what are the assumptions in exploratory factor analysis or factor analysis? The first assumption we are talking about, the data should be either in interval or ratio scale. So, if you want to run or conduct the exploratory factor analysis or the factor analysis, our data should be in interval or ratio scale. So, that is the number one condition. Second, we are talking about the sampling adequacy. So to find out that our data is the appropriate sample size is there or not, to find out we do the KMO, Kaiser-Meyer-Olkin value. That value should be greater than 0.5. So when we will do this factor analysis, we can find out this KMO value. Or a sample of 100 subject is acceptable for factor analysis. So we at least we should take 100 sample size. Or the another method is number of variables. If we are taking like 20 variables, so 20 into 5, so at least that is the sample size should be 100. But in case of the factor analysis, we use this KMO value for sampling adequacy. It should be greater than 0.5. Now the third one, it is saying the overall significance of correlation matrix should be checked with Bartlett test of sphericity. So when the value of significant value of Bartlett test of sphericity is less than 0.05, then we can run factor analysis. So it should be, the significant value should be less than 0.05. So it is, then our data is appropriate to run the exploratory factor analysis. Now it is saying that the next point, fourth point, multicollinearity, but no perfect multicollinearity. Because what exactly we are doing in factor analysis, we are combining the similar type of variables. So unless and until the variable should be similar, it cannot come together, or we will not find the Karl Pearson coefficient should be on the positive or negative side. So that's why the collinearity, multicollinearity is required. Multicollinearity is required, but it should not be perfect multicollinearity or the singularity. Singularity, when call it the perfect multicollinearity or singularity, when the Karl Pearson correlation coefficient will be 1 between the two variables. So what it is saying, the factor analysis is an interdependence technique. There should not be perfect multicollinearity between the variables. Multicollinearity will be there, but it should not be perfect. So like what we can say, our data, our Karl Pearson correlation coefficient between the variable should not be greater than 0.7. In this case, we can take 0.8, 0.9 also, but it should not be 1. But mostly we consider 0.7. So our value should not be greater than 0.7. So the Karl Pearson coefficient value between all the variables should not be greater than 0.7. The another thing we are talking about, these are the assumptions: no outliers, normality and linearity. So these condition, if we are able to fulfill, there should not be outliers, the normality condition should fulfill, or the relationship between the variables should be linear. But if we are not able to do so for these three assumptions, like no outliers, normality and linearity, but if all the above four conditions are satisfying, then we can go ahead for exploratory factor analysis. But if we are able to do, if we are able to satisfy these three conditions also, then it is well and good. Otherwise, if it is not also, we are not able to satisfy these last condition, then also we can go ahead if all four conditions are okay. Then these are the terminologies you can see here. Terminologies used in EFA, exploratory factor analysis. First one, we are talking about the descriptive statistics. Then we are talking about the Bartlett test of sphericity. Then Kaiser-Meyer-Olkin, that is the KMO test. Then communalities, eigenvalues, total variance explained, principal component analysis. Then the factor loading. Then criteria for determining the number of factors, rotation method, and the last one is the scree plot. So these are the terminologies we will get in the output of EFA. So we'll explain one by one theoretically, and when we will get the output in SPSS, then also we'll discuss all these points. So first one, you can see a descriptive statistics. As you know, what is the descriptive statistic? The descriptive statistics of factor analysis provides mean value, standard deviation, and sample size of the variable. So in the output of SPSS, you will, in the descriptive statistics, we will get these 3 points only: mean value, standard deviation, and sample size of each variable. Then the second, we have, as discussed, Bartlett test of sphericity. So a significant result, that is the significant value should be less than 0.05, indicates that matrix is not an identity matrix, that is the variable do relate to one another enough to run a meaningful exploratory factor analysis. If our value is less than 0.05, then we can run exploratory factor analysis. Then we are talking about the Kaiser-Meyer-Olkin test KMO value. So we are, if the values, the KMO value is in 90s, then it is known as the marvelous. If it is in 80s, then it is meritorious, you can see here. If it is in 70s, then it is middling. Then if it is in 60, then the mediocre. Then if it is in 50s, then it is miserable. And if it is less than 0.50, that is 50, less than 50s, then it is not acceptable. So our KMO value should be greater than 0.5. Then we can say that our sample is adequate to run factor analysis. Then you can see here the communalities. It is one of the data that we'll get in output of SPSS of EFA. So what it is saying, a communality is the extent to which an item correlates with all other items. So higher communalities are better. If communalities for a particular variable is low, that is between 0.0 to 0.4, then that variable may struggle to load significantly on any factor. So that variable, if any variable whose communality value is less than 0.4, then that particular variable will not going to load in any of the factor. So what it is saying, the minimum communality value should be 0.5. If it is less than 0.5, then we can eliminate that particular variable and we can report that also in our research paper. Then we are talking about the eigenvalues. What are the eigenvalues? Eigenvalues are also known as the characteristic roots. Eigenvalue shows variance explained by the particular factor out of the total variance. So it will give you what are the variance explained, and then what we are talking about, from the communality column we can know how much variance is explained by the first factor out of the total variance. So in eigenvalue, if it is greater than 1, then those factor only we consider for that particular for the variables, and the eigenvalues should be greater than 1. So it will give us, so all the eigenvalue will consider whose values are greater than 1, how much percentage is explaining the entire concept. So it should be greater than 60%. It should be greater than 60%. So all the factors should explain, if we will combine all the factors, those eigenvalue is greater than 1. So combining all these factors, it should explain more than 60%. Then we are talking about the total variance explained. So the total variance explained table provides eigenvalues and percentage of variance and the cumulative percentage of extracted factors. So in total variance explained table, we will find out eigenvalues, you will find out. So in which I have already discussed, the values, eigenvalues greater than 1 we will consider those factors. Then the percentage also we will find out, and the cumulative percentage, as you know that if we will add the percentage one by one, then we will find out the cumulative percentage of the extracted factors. So that is known as the total variance explained. In this table all these values will get. Now principal component analysis. So it is one of the unrotated method through which we extract the factors, and it shows certain pattern of the data. So what it is saying, principal component analysis is a technique used to find the variation and bring out the strong patterns in a data set. So whatever the data we have for exploratory factor analysis, it will give us the pattern on specific factors. Then we are talking about the factor loading. What is the factor loading? Factor loading is basically the correlation coefficient for the variable, whatever the variables we have considered for our research and the factor. So this is the factor loading, is the variable and the factor, the correlation coefficient. So the factor loading shows the variance explained by the variable on that particular factor. So in which we can find out which variable is loaded to which factor. So that we'll find out from factor loading. Then you can see here the criteria for determining the number of factors. How we'll find out how many factors we should consider. So what it is saying, I have already discussed this. Eigenvalue is a good criteria for determining a factor. If eigenvalue is greater than 1, you can see here already I have said this statement, greater than 1, we should consider that a factor, and if eigenvalue is less than 1, then we should not consider that a factor. So all these factors whose eigenvalue are greater than 1, all these factors we can consider for our study. So we have to see where is the value is greater than 1. Now rotation method. So rotation method makes it more reliable to understand the output. It minimizes the cross loading of the variables. So as we have discussed the PCA, the principal component analysis, in which you will find out how the variables are loading to the different factors. But in case of principal component analysis, it may happen like one variable may load to the two or more factors. So it minimizes, the rotation method minimizes. In case of when you will apply rotation method, the one variable will load to only one factors. So it minimizes the cross loading of the variable. So that's why we use rotation method. So one variable will not go to factor number 1 also, factor number 2 also, and factor number 3 also. It will go to only one factor. So that the PCA was the unrotated method, this is the rotated method. So in case of unrotated method, there may be the cross loading of the variables in 2 or 3 different factors. So it minimizes in case of rotation method. Now the scree plot. So in multivariate statistics, a scree plot is a line plot of the eigenvalues of factors or principal components in an analysis. So the scree plot is used to determine the number of factors. The eigenvalues also we are using to determine the factors. In the scree plot also, number of factors to retain in an exploratory factor analysis. And this scree plot is also based on the eigenvalue or the principal component to keep in a principal component analysis. So scree plot is a diagrammatical representation, and it is based on the eigenvalue. It will also tell you that which are the factors we can consider or how many factors we can retain for this particular study. Now we are considering one case study related to exploratory factor analysis. So you can see here a case study related to this EFA, and I have taken this case study from the book of Dr. Rajendra Nargunkar of Marketing Research. What it is saying? Delta car manufacturer wants to launch a small car into the market. For this purpose, they have surveyed 109 respondents about their perception and image attributes of small cars. So the question were asked to each of them, all answered on a scale of 1 to 7 point scale. So 1 is equal to strongly disagree, 2 is equal to disagree, 3 is equal to somewhat disagree, 4 is equal to neutral, 5 is equal to somewhat agree, 6 is equal to agree, and 7 is equal to strongly agree. So this is a 7 point Likert scale we have used for the collection of data. Now we have converted this case study in the form of a topic. So what is our topic? A study of factors affecting customer perception and image attributes for a small car. So this is our topic. So we are trying to find out the factors because our topic is related to factor analysis. Now these are the 10 questions we have considered. You can see here. So the price of the car should be reasonable. Fuel mileage of car should be at least 20 km per liter. Third, a small car should be easy to maintain and to be serviced. Seating should be comfortable for 4 adults. A small car should have adequate leg space and headroom. Brakes are the most critical part of a small car. Collapsible steering column should be standard equipment in all the new cars. Power steering is a must. Then ninth, interior accessories of a small car should be attractive and adequate leg space for luggage. So these are the 10 variables you can say, statements you can say, and we have to get the responses for these questions or the statements on 7 point scales as we have defined. So these are the questions. Now on the basis of our topic, we have formulated our objectives. So these are our 2 objectives. So you can see here, to study the variables of customer perception and image attributes for a small car. So first of all, we have to find out the variables, n number of variables we have to find out for the customer perception and image attributes. And then the main objective is to determine the factors affecting customer perception and image attributes for a small car. So this is our main objective. We try to find out the factors, and the variables we have already identified. We have 10 variables in the form of statements. So we have taken. Now data analysis we will do. We have our data with us. So you can see here, this is our data. These are the 10 questions. Price is reasonable, fuel mileage, easy maintenance. So all this data is there with us. So this is on 1 to 7 point scale. 1 to 7 point scale, data is in interval scale. So what was the first assumption of EFA? Our data should be in interval or ratio scale. So our data is in interval scale. So you can see here, this is our data of 109 respondents. Now our data sheet is in Excel. So we'll import this data in SPSS for the analysis. So we'll go to file, then open, then data, then our data is in desktop. So we'll go to desktop. In desktop, our data is in exploratory factor analysis, and then it is in .sav format, but our data is in Excel format. So we'll click here Excel. So we have got, you can see the factor analysis delta cars. So we'll click this, okay, and then once again we'll do okay. So we have got our data in SPSS. So this is our data view and this is our variable view. So you can see here. Now our data is in scale because it is in interval scale. So in SPSS, measure will be nominal, ordinal, interval or ratio. So the four types of scale of measurement are there, but in SPSS scale represents both interval and ratio. So we'll put here scale, all the data will put here scale. Now we'll define also the values. So 1 is equal to strongly disagree, 2 is equal to disagree, 3 is equal to somewhat disagree, 4 is equal to neutral, 5 is equal to agree, 5 is equal to somewhat agree, we'll remove this, 5 is equal to somewhat agree, 6 is equal to agree, and 7 is equal to strongly agree. So these are the 7 points we have considered for our data collection. So we'll copy all this into all the questions, 10 questions. So we'll copy it, our data. These are the values we have defined for all the 7-point scale. Copy, we'll copy this for all the questions. Okay, okay, and then this is the last one. Okay. So what was our first assumption? Our data should be in interval or ratio scale. So our data is in interval scale. Second, we'll check the multicollinearity. We'll go to direct analyze and then correlate. In bivariate, we will only find out the correlation. So our data, our correlation coefficient should not be greater than 0.7. So we'll okay. So we put okay. So you can see here all our data, the correlation coefficient on the upper part 0.671, all these values are there. It is not greater than 0.7. So all are less than 0.7. So all data. So multicollinearity is not there, and these are the relationship is there. You can see here somewhere it is not there, but somewhere 0.671. So this is the relationship between the variables. Two variables are there, but multicollinearity highly they are not correlated to each other. So strong multicollinearity is not there, singularity is not there, perfect multicollinearity is not there. So it fulfills our second assumption. So first assumption was interval scale, second was no, there should not be strong multicollinearity. So again we will close this output, and then again we'll go to this factor analysis. For factor analysis we'll go to analyze, and then you can see a dimension reduction. So in dimension reduction we'll find factor. So two assumptions we have seen, that is the interval scale and then strong multicollinearity or singularity is not there. The remaining two are the KMO value should be greater than 0.5, and second, the significant value of Bartlett test of sphericity should be less than 0.05. So that we'll find out in the factor analysis itself. So we'll select all these variables and we'll take it on the right side, and then one by one we'll go descriptive statistics, univariate, then you can see here the coefficient, significant value, determinant, KMO value, and then anti-image. All these things we can find out. These two are not required, inverse and reproduced. then continue. Then we'll go to extraction. In extraction, by default, you can see here the principal component method is there. So in principal component analysis, what actually it is doing, so whatever the factors you will find out, all the factors will be, they will be different factors. These factors should not be related. But when we want to find out the factors should be related, then we can use the principal axis factoring and all. So the most appropriate for the different factors is principal components. And then also we'll find out the scree plot. We have already discussed theoretically. Now based on the eigenvalue greater than 1. As we have already discussed, the factor whose value is greater than 1, those factors only we'll consider. Or secondly, what it is saying, the fixed number of factors to be extracted. If the researcher wants that he wants only these number of factors, 3 factor, 4 factors, then you can put here. Accordingly, you will find out. And this is the maximum iteration for convergence. That is the internal, you can say that this is how many iteration it will be happen internally to find out the loading. So then we can go to continue. Then we'll go to rotation. So in rotation, you can see here the various methods are there. You can use Varimax, direct oblique method. So mostly we use is Varimax, and I have used all the methods, and more or less you will find out all the values are same. So and then the rotated solution will find out, and then loading plots, that is the graphically the plot you can find out. So that also you can click and then continue. Then the scores, it is when we'll find out the factors, then we will click this. Right now we'll keep it is like that only. Will the second time we'll click this so that we can find out the factors. So this value, either Anderson-Rubin method, Bartlett method, or regression method, mostly we use the Anderson-Rubin method to find out the factors. We'll second time we'll do it. Right now we'll not select this. So continue and then options. So that also sorted by size, surface small coefficient, absolute below value, that is the 0.10 you can see here. So that also we'll discuss next time. So when again we'll do the analysis and we'll show you. Initially what we will get, that I will show you. So then okay. So this is our output, you can see here. This is our output. So in the first descriptive statistics you can see here, that is this is the mean value of each variable. This is the mean value of each variable, you can see here, mean value, that is mean value, standard deviation, and analysis. This is the sample size 109. Now you can see here, this is our correlation matrix. We have already seen in case of to find the multicollinearity on that particular aspect we have seen. So you can see here again this is the correlation matrix is there, and these are the significant values we have. So to run the exploratory factor analysis, your determinant value should be greater than 0.00001, 0.401. It should be greater than, and it is there. So 0.201 is greater than 0.00001. So this determinant value should be greater than 0.00001, 4 times 0 and 1. Then you can go for this factor analysis. So the value is appropriate. Our value is 0.021, which is greater than 0.00001. So that is there. So it gives us, again we are coming to this KMO value, Kaiser-Meyer-Olkin measure of sampling adequacy, you can see here 0.681, which is greater than 0.5. It is in the 60s. So it is, our value is good. So we can go ahead for this factor analysis. Also Bartlett test of sphericity, our significant value is less than 0.05. So all our 4 condition data should be in interval or ratio. There should not be strong multicollinearity or singularity. Our KMO value should be greater than 0.5. Bartlett test of sphericity significant value should be less than 0.05. So all these conditions are satisfying. Now what it is saying, the second you can see here, this is the anti-image matrices. Anti-image matrices, we need not have to see this anti-image covariance, we directly come to the anti-image correlation. This is in the standard format. So here what it is saying, measure of sampling adequacy MSA. So all the diagonal value should be greater than 0.5. Then you can say that your all variables are greater than the sample size for all the variables are adequate to run exploratory factor analysis. KMO value gives you the overall value for the sample adequacy. This anti-image correlation, the diagonal value will give you this is the for each variable, that variable is adequate, uh, sample size is there or not for that particular variable, that it is showing. So you can see here all the diagonal values are greater than 0.5. I have copied it in Excel sheet also. I will show you. So this is the thing. Now you can see here the communalities. I have told you the value should be, the communities value should be greater than point, at least it should not be less than 0.5. The minimum value should be 0.5. Otherwise we should remove that particular variable. So you can see here, so all these values are greater than 0.5. Only this interior attractiveness, this value is 0.271. So this value, you can see this value will not relate to other variables. It should not load with the other variables, that will find out. Now what exactly and from where these extraction values, these values, from where these values we are getting, so that also I will tell you from where we are getting. So we'll go to this, you can see here, and then again we'll discuss about first extraction. We can see here, these are nothing but these are the square of the component variable. I will show you from where these values are coming. Now you can see here the total variance explained. So I have told you that we'll consider those factors only whose eigenvalue is greater than 1. So these three factors eigenvalue are greater than 1. And I will also tell you from where these values are coming. From where these values are coming, from where this value came, all these things I will tell you. From where this value is, came, that is for 27, it is by 2.716 divided by 10, because there are 10 variables are there. Divided by 10, so we will find out 0.27155, and if we will multiply it by 100, then you will get this value. Similarly for this divided by 10, you will find into 100, you will get this value. So similarly you will get all these values, and then cumulative value, this value, then this value, addition of these two, and so on. And these are the total, you can see here this, and this is for the rotation sums of square. So this is for the rotated and this is for the unrotated values. For the rotated also, these are the eigen values, and 2.472, if we divide by 10 you will get, and into 100 divided by 10 into 100. Why 10? Because there are 10 variables are there. Divided by 10 into 100, you will get this value. Again this divided by 10 into 100, you will get this value and this value. So what it is explaining, these three factors, we have seen that from these 10 variables 3 factors are extracted, and these 3 factors explaining 68.636%, and I have told you the at least it should be 60%, so it is 68%. So our study or our data, whatever we have extracted is good, so we can go ahead with that particular extraction factors. So it is because these extraction factor explaining 68.63%. Now also I have told you that from the script plot also you can consider how many factors you can keep or you can retain. So you can see the value, the factors whose values are greater than 1. So the how many factors? 1, 2, 3. So these are the 3 factors whose values are greater than 1. You can see 1 is here. So how many factors are above 1? These 3 factors. So we can extract 3 factors, and we have already seen in the total variance explained. Now you can see here from where we got the communalities values, extraction values. So if we will square this value 0.358, square of 0.358 plus 0.284 square plus 0.061 square, then you will get the communalities value, first communality value, this one. Similarly for the second one, third one, fourth one. So if we will square all the variables, all the 3 variables, from all the 3 factors, you can see here you will get the communalities values. So square of this, square of this, square of this, all the addition, first one, second one, third one, and fourth one, you will get the communality value. Now from where you will get the eigen values? So this eigen value, if you will square this plus square of this plus square of this, all these factors, if you will these are the nothing but these are the correlation coefficient. These variable, these are the factor loading we can say that the factor loading. So this is the first variable and this is the first factor. So the square, what is the correlation coefficient of first variable with first factor? This one, 0.358. For 2 it is 0.824. It is on the higher side, and so on. So like that. So if we will square this one plus square this one plus this square this one, so you will find out this value. So these are the eigenvalues. So if we will go vertically downwards on the component matrix, then you will find out the eigenvalues. If we will go horizontally, then for one factor, second factor and third factor, then you will find out the communalities. So from this value you can find out. I will show you in Excel also. And then this is the unrotated matrix. Through the principal component analysis, you can see here, this is the unrotated matrix. So these are the values you can see. So why we do the rotated matrix, you can see here. For power steering, the here the loading is also high on the side 0.22, and in case of 3 also. So there is a chances of cross loading in case of unrotated matrix. So we do the rotated matrix, so it will minimize the cross loading. So you can see here the price is reasonable, so only this second factor it is loading. Then again fuel mileage, second factor loading, all are less. Then easy maintenance, second is loading. For this comfortable, first is loading. Adequate leg space, first is loading. Luggage, this one is loading. So these are the things. Similarly, so when we do the rotated matrix, your factor loading should be with only one factor. It minimizes the cross loading. So that's why we do the rotated matrix. Okay. So these are the things. And now we have to consider, so which are the variables are related. So you can see here in the first factor, this comfortable 0.860, adequate leg space 0.859, and the last one luggage space. These variables have higher values. These three variables have higher values. All the other variables are lower value. So these are the three variables in factor number 1 we can consider. Similarly, for the factor number 2, you can see here, price is reasonable, higher one, fuel mileage, higher one, easy maintenance, higher one, and all the remaining values you can see on the lower side. Similarly, for this third factor, you can see the brakes, that is 0.840, collapsible steering 0.781, and power steering 0.825. These three are higher, all the other variables are low. So these variables are related for third factor. These variables are related for second factor. These two and these variable are related to first factor. So you can see here. So same thing you can see here in the diagram also. It means you will find out which variables are related to each other. So you can see a price is reasonable, fuel mileage, easy maintenance. So these are similar to each other. So you can make one factor from these variables. Second, adequate leg space, luggage space, and comfortable. You can make one factor from these variables. Third one, brakes, collapsible steering, and power steering, one factor you can see. But you can see here the interiors should be attractive. It is somewhere else. Neither it is going in this part or this part. So you can eliminate this because his community value is very less, 0.271. So that's why it is not relating with any other variable. We have seen in the community value, all the other variables community values are greater than 0.5. Here it is 0.271. So it is not related. So you can remove this particular variable and you can report in your paper also. Now you can see here, it is difficult to see these values. So there are some lower values are there, higher values are there. So how to find out a good thing, the remaining value we should eliminate. So again, what I will do, I will close this. And again we'll run. This dimension reduction factor analysis, all will be there. Then we'll go to score, and again we will find out the factors also. And in factors we'll go to the Anderson-Rubin method. So till now we do not have factors. You can see here no factors are there. But when we'll click that, you will find the factors in the next output. So I will go to analyze, dimension reduction. So we'll go to score. So we'll find out save as variable. So and then Anderson-Rubin method will apply, and through which we'll find out the factors. So we have seen in our analysis there are 3 factors. So you will get 3 factors. Okay, continue. And then in the option, what we will do, we'll sort it by size and suppress small coefficient here 0.10. So whatever the value greater than 0.10, we have got all these values in our component matrix, rotated matrix. So we do not want the value less than 0.7. So all the other value should be eliminated. So absolute value below 0.7 should be eliminated, and then continue, and then continue, and then you can see here. So all this data we have already explained. Directly we'll go to this. You can see here. So we'll go to rotated matrix directly. Rotated matrix. You can see here all the other data are eliminated below zero point 0.7. So for this first factor, these are the three things: comfortable, adequate leg space, luggage space. So this is the thing. For this second factor, the price is reasonable, fuel mileage and easy maintenance. These are the three. By combining these three variables, you can consider one factor. These three variables, one factor. And then the third one, brakes, power steering and collapsible steering. You can see here collapsible column, that is these are the three variables. So through these three variables, this is the third factor. So you can see here all the other variables are eliminated. All the other variables are eliminated. So how we can report this data? So you can see here how to report this data. So reporting of result. The data collected for analysis holds all the assumptions of exploratory factor analysis, because we have already satisfied all the assumptions. So in factor 1, the variable 4, 5 and 10 have high loading, that is a 0.860, 0.859, 0.852 on factor 1. This indicates that factor 1 is a combination of these three variables. Therefore, factor 1 can be interpreted as combination of seating should be comfortable for 4 adults, variable 4. A small car should have adequate leg space and headroom, variable number 5, and adequate space for luggage, variable number 10. Hence, factor 1 can be named as. So, by combining all these three variables, what name we can give? That is the spaciousness. So, our variable, our factor, first factor should be spaciousness by combining all the three variables. Now we'll go to the second one. So in the rotated factor matrix, we notice that variables 1, 2 and 3 have loadings 0.899, 0.845 and 0.835 on factor 2 respectively. This suggests that factor 2 is a combination of these three variables. So thus this factor 2 can be interpreted as a combination of, what are the three variables? The price should be reasonable, variable number 1. Fuel mileage should be at least 21 km per liter, that is the variable number 2. And third, easy maintenance and servicing, that is the variable number 3. The suitable phrase which captures the essence of all the three original variables, which combine to form the underlying concept or factor, in this case factor 2, can be named as, so the factor 2 can be named as economical. What we are talking about, the price should be reasonable, fuel mileage should be 21 km per liter, and the maintenance cost should be less. So what we are seeing, the customers are seeing, that is the car should be economical. So our second factor is economical. First factor was spaciousness. Then the third one. In factor number 3, the variables 6, 7 and 8 have high loading, that is the 0.846, 0.781 and 0.825 on factor 3. This indicates that the factor 3 is a combination of these three variables. Therefore, factor 3 can be interpreted as a combination of brakes are the most critical part of a small car, variable number 6. Collapsible steering column should be standard equipment in all the new cars, that is the variable number 7. And the next is power steering is a must, that is the variable number 8. Hence, factor 3 is a combination of all these three variables. And what should be the name? The name is safety. So we have converted these 10 variables into three factors we have seen. So now again, if we'll go to this SPSS file, you can see here these are the three factors we have received. By Anderson and Rubin method, these are the three factors. Later on, you can see the demographic variable you can use. How the gender think about factor number 1. Is there a significant difference with gender, age group, educational qualification, income group? With all the factors you can apply, so that you can find out. Next, for the hypothesis testing, you can do that. But initially, our work is to find out the factors. Next important thing, again in the output, I will just show you our Excel sheet. in our Excel sheet I have copied all these things. So you can see our output. So this is the cumulative we have received, so that I have copied here, you can see here. And the total variance explained also I have copied here, and this is the earlier component matrix we have done. So if we will square of this, square of this, square of this, then you will get this value. For the second, square of this, square of this, square of this, you will get the second value, and so on. So in this way you can find out the cumulatives values. Now how will find out this value? The first one, this eigenvalue. If you will square this plus square this, all this square this, you will find out this one. Similarly, for the second factor and then third factor. So till now we have considered only three factors. Then what about the remaining factor number 4, 5 and 6? I will show you how to get for the other factors also. All these variables, all these values from where we are getting, that also I will tell you. So what we have to do, again we'll go to our this SPSS. We have already concluded what to write, that we have already concluded, but again I will show you how we will get all this data. So we'll go to this dimension reduction, factor analysis, and then scores. In scores it is not there, in options, not in options, that is in the rotation, not rotation, also in extraction. So we'll consider the fixed number of factors. I am putting here 10, fixed number of factors. We have 10 variables. I just want to convert the 10 variables into 10 factors. So what is the result will come, that we will see. Already we have discussed what is the output, how to do it. I am just trying to show you how to get the values, how we are getting the communities values, how we are getting the eigenvalues, total variance explained, all these things, how we are getting that, just I want to show you. That's why this extra thing I am doing. And then okay, so you can see here, so we have considered all the 10 variable. We need not have to explain all these things. So extraction matrix, so this is our we have to go down. This is our component matrix, component transmission matrix. Okay, just a moment. Already we have removed this. Once again I have to do it, because what I have done in this, just a moment, in dimension reduction, in options, what I have done, I have put this 0.7. I have to keep it 1.1. Continue, and then okay. So you can see here, we'll directly go to this. This is the table. 0.1 adequate leg space component matrix. This is our 0.1 component transmission matrix. So this will consider this matrix. Copy. So already this is there. You can see here this data is available. Just a moment, this data is not available. Earlier it is 0.06, 0.30, 80 component matrix. Just a moment, I have to close this. We'll go to analyze, dimension reduction, extraction, 0.10. Okay, continue. Sorted by size is not required. Total, whatever the value we had earlier. So this is our data. This is our component matrix. You can see here. This is the same matrix. Copy. So this is our data. Factor analysis. Sorry. This is our data. You can see here. This is our data. Then again, we have to score this data. Square of this. This is the correlation coefficient with all the 10 factors. So these are that all the 10 factors are there. All these 10 factors. First variable will factor number 1, factor number 2, factor number 3, 4, 5 and 6. So now we'll do the square of all these values. So that what we'll do is equal to this, and then we'll find out the square of this square, and then 2, and then do this, and then we'll drag this. So we'll find out the values, all the values, all these values we'll find out, and then all these values are there. So you can see here, if you all these values are 1 1 1 1, all these things, this is 2.716, 2 point is, all these values will be this. The eigenvalue, if you will go to, these are the values, these are 2.7, and all these values you will find out. These are the values, these are the values we have. Same thing, same values are there here, you can see here, same values are there. If we go down, these are the same values. So these are for 10 factors, but we have extracted only 3 factors. So when we have extracted these 3 factors, these are the values you can see here, and these are the eigenvalues you can see here. So I will remove the remaining values. So what we'll get, you can see here. So from this I will consider till only 3. So I will remove all the remaining values, all the remaining values, all the remaining values. I am removing it, deleting it, deleting. So you can see here, these values are same, this value and this value. So that's why from where we are getting this value. This already we have got in SPSS of EFA. These are the 3 factors SPSS had given. What I have done, I have considered all the 10 factors, and then I have removed the remaining 4 to 10. Then I am getting the same result. Similarly, you can see these are the eigenvalues for the 3 factors. And when I have kept all the 10, you will get all the 10 values. Wherever we have, you can see here, all the 10 values. These are the eigenvalues: 2.716, 2.273, 1.875. So these are the values. These are the values through which you can find out. Also, in case of anti-image, if you want to check your diagonal values are greater than 0.5 is there or not, what we'll do, we'll select all the values. You will select all the values. We'll go to conditional formatting, higher cell rules greater than, and then you will put here 0.5, and then OK. So you can see here, you can find here, all these values are greater than 0.5, 0.5. So your measure of sampling adequacy is correct. So in this way you can find out each and every value in exploratory factor analysis in the output of exploratory factor analysis. So these are the things we have got in SPSS. Now you can see here, so these are our outputs. These are the 3 factors we have. The first factor, our first factor was spaciousness, second factor was economical, and the third factor was safety. So these are the factor analysis. You can see how to go within SPSS. So this is the process through which you can do this factor analysis in SPSS, exploratory factor analysis. And thank you.